Thank you for viewing this recorded Reliable Automatic Sprinkler Company webinar. Should you have any questions regarding this presentation, please feel free to contact Reliable Technical Services at 800-557-2726 or email us at techserve@reliablesprinkler.com. For upcoming webcasts and an archive of past webcasts, please visit reliablesprinkler.com/webcasts. Once again, thank you and enjoy the presentation.
Thank you everyone for attending today. Welcome from beautiful upstate South Carolina. Another beautiful day after we got scraped by Fred yesterday. The sun came out this morning and we are back in business. As always, we're going to start with the disclaimer. The views expressed today are not those of NFSA, NFPA, UL, or FM. They are the sole opinions of Reliable Automatic Sprinkler Company and more accurately, myself. So what are we going to talk about today? We're going to talk about flexible product. A lot of flexible product being used these days. That wasn't always the case. Let's take a quick look at what the agenda is going to look like today. We're going to have a brief history of flexible drops. We're going to talk about the development and testing of drops, the UL and FM test standards, and look at some of those tests. We'll then look at the massive NFPA 13 requirements, and by massive I mean 4 statements in NFPA 13. Some design considerations to be aware of. Some best practices, maybe a couple not just for flexible drops, but for your day-to-day design as well, if that's your job. And then we'll talk quickly about some future enhancements that may be coming. And finally, as Lindsay mentioned, we'll follow up with the question and answer session at the end. So as I was putting the presentation together, I came across this, and I kind of looked at it and I thought, well, this has got some interesting stuff in here. You know, Bruce Lee would have been talking kind of in the philosophical sense with this statement, but there's a couple ways that it actually kind of applies to what we're doing today. You know, from a seismic standpoint, and we'll talk a little bit about that, if we anchor something and anchor it on 2 ends, and those 2 ends move in different directions, if we don't have some flexibility in there, things will break. So we're going to talk a little bit about that. And then secondly, kind of on the philosophical side of things, I recall when first flexible drops started hitting the market, and the vendors were coming in trying to sell these when I was back in my contracting days. And the initial reaction was, this will never fly, right? This is never going to work. We've seen a lot of things come and go in the industry, and this is a flash in the pan. So there was some skepticism there. And I think this is a good reminder as we're sitting here 20, 30, 40 years later, that we need to stay flexible in our thinking and not be so rigid. So when this product came out, which is the first Sony Walkman, is when I started in the fire protection industry. I'm going to let you think about when that might have been and take a guess. And again, like I said, when I first heard of flex drops, I thought, like a lot of other products we have seen come and go, particularly joining methods, right? Things to replace threaded and grooved fittings. We've seen a number of those come and go in the industry. Pipe types, different pipe materials have come and gone in the industry. So over that 40 plus years that I've been in the business, I've seen a lot of stuff come and go. And I was wrong about the flex drops, obviously, today. So the other reason I like this slide is it gives me an opportunity as a shameless plug for my 2 football teams. Go Hawks, go Cougs. And in case you're wondering when that first Sony Walkman hit the market, 1978. So where do ideas usually start, right? We often hear the phrase that we've got a solution looking for a problem, but in reality, most ideas generally start because we have a problem. And so back in those late 70s, early 80s, you know, you've heard all us old guys talk about, you know, how we walked uphill in the snow to school both directions, and how we had, you know, 4 sprinklers to choose from. There were a few more than that, let's be honest, but But in reality, we had 5.6K and we had those great big 8.0K uprights. And man, we struggled to put those in area density systems. Washington State, for instance, had a spec warehouse density, very popular, 0.39 over 5,600. San Diego, we used to do 0.33 over 3,000 as a spec warehouse density. So we didn't have a lot to choose from back then. And when we got into those finished ceiling areas, we had and we used a lot of these. We let's face it, we installed a lot of 401 style extendable canopy sprinklers. But the kind of the cat's meow back in the day was a sprinkler not unlike this one, probably one of the greatest sprinklers in the world, the Reliable Model G Recessed. It was kind of the pendant sprinkler of choice. Occasionally, you got a request to install some of these guys, right? The concealed versions. Wow, these fancy, expensive flat plate concealed sprinklers. And this particular version of the Reliable sprinkler with the fixed frame back in the day had, well, we would say it had an 1/8 of an inch adjustment, but in reality, let's face it, there was no adjustment in this fire sprinkler. It's what we had, and when we had concealed type sprinklers, when I came up in the industry, we cut drops as close as we could. We tried to make them fit. When they fit, it was great. When they didn't, the fitter did his job and he made those adjustments. But it was hard pipe down to within an 1/8 of an inch. It was tough to do, right? It was really kind of a no-win situation. So there's the problem, right? We need some vertical adjustment. How do we do that? And the earliest solution that I can recall for the vertical issue was these style of drops, which are still available on the market today, right? Usually a double O-ring telescoping style adjustable drop nipple. These would have somewhere around the neighborhood of an inch plus or minus adjustment. That would allow you to allow that slight adjustment of the concealed sprinkler, variations in the ceiling height, which are known to occur. You could get within that inch and a half maybe range and spin these up and down. And we were able to accommodate the vertical. So it, again, still available today. I don't know how much they're being used, but they're out there. So then kind of the next thing that happened was, some changes to the actual concealed sprinkler. Again, here's the next generation of Reliable, which is still we call a fixed frame sprinkler, but we put the deflector on some telescoping pins. We also extended the thread length on the cup and how that cup attaches to the concealer. And we were able to now get in that neighborhood of, a 1/2 inch up and down. So we could maybe get away from the adjustable drop nipple in some cases, or as you can see on the image there on the right, Reliable offered and still does on one particular sprinkler. We actually brazed these sprinklers into the adjustable drop nipple, so you could purchase them that way. And now you've got, particularly with the concealed, some adjustment range to go up and down with those sprinklers. And it was good. It handled the issue until we see again kind of another issue come up. And this had to do with tegular or suspended acoustical ceiling tiles, 2x2, 2x4. I mean, back in the day, 2x4 was really popular. Now we see all kinds of sizes and shapes of this. But we have architects saying, well, we'd like to have that sprinkler head centered right up there in that ceiling tile. Now, I'm sure centering in ceiling tiles was around much earlier than 1978, but I wasn't. So for me, we started hearing about this, and so we would draw the reflected ceiling plan out, right? Usually back in the day, right? For the younger guys, we drew on the back side of a sheet of transparent vellum. We drew our sprinklers on the front. And we would attempt, right? We would attempt with everything we had to line up the branch lines over the top of the center of tile and maybe try to drop straight out. And when it worked, I guess it worked. You know, we could be accurate to within the tolerances of threaded makeups and different things like that. But the reality is it was not uncommon. It's probably still not uncommon today for the ceiling installer to change up those borders and maybe start a full tile on one wall rather than splitting it on two walls. There's various ways that those guys look at that, and it was not uncommon at all to have the fitter call up and say, all your drops are right in the T-bar. And then you would come to find out, right, that the ceiling installer shifted. And now what, right? Who's responsible for making that correction? So we had to come up with a way to address that situation. And one of the early solutions, the easiest one, was to kind of compromise with the architect and say, hey, how about we center up in one direction, right? If we have a 2x4 tile, let's say we're going to be centered in the 2-foot direction, but allow us to be anywhere along that 4-foot direction. And we were able to kind of accommodate that simply by adding a swing joint, either down off the bottom or up off the top of the branch line. And by doing that, that allowed us to swing that drop and within that, particularly again, that 2-foot direction to center it up. But that would, of course, move us lengthwise down that 4-foot direction. But again, the architects were like, okay, that, I mean, there was a lot of cases where they said, yeah, centering in one direction, we'll buy it, right? Again, the issue here is as long as the tile goes in like it was supposed to, then things worked. But we had started seeing the same issue where tiles were jumping all over the place. And now we're out having to actually, you know, recut arm overs and recut drops for vertical adjustment. So again, this solved some problems, but it doesn't always work. Then we had the architects coming back saying, no more of this centering in the 1-foot direction, in one direction, excuse me. We really do need centered. And we would see specifications, guys that have been around for a while have seen them centered to within 1/4 of an inch accuracy. And it's like, are you kidding? I mean, this is nuts. Do you realize what this is going to cost to do this? Because we know that ceiling tile may shift, right? Depending on how it goes in. We know that we need to hydro test. We've got to put something in. So we're going to put something in that likely is going to have to be changed out later. So one of the earliest ways to kind of address this issue, and I remember doing this, was architect would specify semi-recessed sprinklers. And we would say, how about if we throw in concealers for you? We'll give you the fancy white plate concealers that blend in if you don't make a center in the tile. So that was an opportunity for an architect to go, yeah, okay, that's fine. I like the looks of those. But then pretty soon it was like, yeah, we not only do we want centered within 1/4 of an inch, we also want concealers. So again, it was kind of this, wow, we're spending a lot of money to make this happen, and we'll look at how some of those costs were driven. But architects get their way, and in order to stay in business, you have to figure something out. So we've got the center of tile issue, and then we start seeing things like this, you know, linear metal ceilings. Again, popular. I don't know how popular they are now, but very popular back in the day. And so with these, you've got a 4 or 5 inch span that you've got to line up within, and be on the spot to cut these, because as they go in is when you're kind of cutting your drops and trimming them out. You don't come back in later and reach over the side of a 2x4 tile to do that. Not only do we like that look, we're going to take these, we're going to put them on some fancy curves like this. So now instead of a drop coming straight down and trying to hit that little 4-foot lateral increment, I've now got to somehow swing that fire sprinkler so that it's parallel to that particular linear panel. So how do we address this, right? With fittings and extra labor. And that's where that cost comes in. And then, of course, what comes along with additional fittings is the potential, anyway, for additional leaks. And then we see things like this. Now we're going to take these weird shapes and we're going to hang them below the ceiling. And everybody's familiar with the issues around cloud ceilings and things like that. You know, if you're in a museum, you might see an airplane hung below the ceiling. You might see a pterodactyl hung below the ceiling. One of the premier retailers, online retailers in their office buildings, they like to hang doors below the ceilings on different angles and pitches. And so anytime, obviously, we're over 4 feet wide, we've got to get fire sprinklers below those. So now we've got this challenge of how to make all of that happen. In addition to all that, we then see another issue that kind of comes up, and it's been around since the dawn of time. Oh, excuse me. That's going to be the next slide. I flipped these at the last minute. So this image here should be familiar to anybody, at least who works in a seismic area. And I put this in here because it's going to help me illustrate a solution that was around for a little while to handle that centering and some other issues. But it also kind of came to me that this option that you see here, this 690 10 coupling option to cross a seismic joint, which still can be used today, has been replaced by, or can be replaced by, something else. And what is that something else? It's a braided flexible hose that allows movement in different directions. So while it's not directly applicable to a fire sprinkler drop, the concepts there are still the same, right? We anchor these on each side of a piece of structure that's going to move independently. We've got to allow some flexibility in there. So I had to use this picture because I couldn't find a picture of what I want. I couldn't remember who made the product, but I do remember it and what it wasn't done necessarily with grooved couplings. It was done with threaded couplings. But imagine at that point if we swung down, broke back under ourselves, and then went down to our drop. So now you've got this 490 bend that at the top and the bottom, you could move this in 2 different directions. And within a particular range, a radius, you could hit center of tile, provided, again, that the ceiling didn't change too much. I would love for somebody to remind me, excuse me, who that manufacturer was. I have an idea who it might have been, but again, in my search through the internet and my files, I couldn't come up with a picture of it. But again, it was a pre-purchased unit that you would put in. It may have included some vertical adjustment as well, but this thing was relatively expensive, and it was kind of short-lived out there. I don't think it's again, I don't think it's around today. Would love to have somebody maybe back in my era remind me of who that was. So, but again, costly in terms of leak potential, additional labor, and just purchase price. So again, that was kind of the next generation solution anyway to centering of tile and hitting odd shapes and things like that hanging below a ceiling. So now another contributing factor, been around again since the dawn of time, right? 1989 World Series earthquake up in San Francisco, Loma Prieta, 6.9 magnitude, $13 billion in today's dollars of damage. 1994 Northridge earthquake, just north of LA, 6.7 on the magnitude. I guess we don't use Richter scale anymore, I've been told. That particular earthquake, $20 billion of current day dollars. So what we learn from these, aside from the human tragedy and the structural tragedy and all that, is that if there's one thing you'd like to have in good, solid operation following an earthquake, it's something like your fire sprinkler system, right? We don't need them falling out of the air and all of a sudden running massive amounts of water that could be used somewhere else. So there became this focus on, what do we need to do in the seismic world with fire sprinklers? And again, for folks that have been doing this for any number of years, we saw kind of this escalation of requirements in the NFPA standards, kind of in the, the 1989, 1991, 1994, kind of up into the 2007 edition when we started to reference the ASCE and things like that. And we've still seen this this ongoing attention being paid to seismic. So how do we address things that are going to move in different directions? And with regard to flexible drops, it's things like an acoustical ceiling, right? That ceiling, if it's not braced, could sway separately from the structure up above. So if we hard pipe things in, we may have an issue there. Cloud ceilings, big ducts that are hanging from the structure. So depending on how those things move, we might have an issue with our fire sprinkler system. So the solution, right? Now, everybody knows that Reliable is a relative newcomer to the flex market with our Rasco Flex product, but how far back do these things exactly go? From what I can tell, the first flexible drops kind of originated in Japan in the 1980s. I would suspect, as everyone could probably guess as well, the response was probably to some seismic needs over there. It seems from my research that the first viable US drop was made by Flexhead, and it patents in the year of the Exxon Valdez disaster. And I'll let you think about when that was. You didn't know you're going to get a little history lesson today. So at last check, just simply going through the FM approval guide and looking at flexible manufacturers, there were over 50 vendors listed on the approval guide. So in that, again, 20, 30, 40-year period, we've seen a lot of different vendors enter this market. Anyone, by the way, care to guess? Exxon Valdez, 1989 was that first patent. And forgive me, Flexhead folks, if I'm wrong, but that's what I was able to find. So let's look at that's kind of the history. Things have remained, pretty stable since then. Once the test standards are written, we have 2 test standards that we primarily work with. There could be more, particularly on the international market. UL 2443 and Factory Mutual 1637. So we're going to take a look at both these documents. There are some similarities. There are some differences, as you can expect with these 2 testing agencies. Let's take a look at just a couple basic things, and here are some things that the 2 agencies kind of more or less agree on. So both documents reference in the scope clean rooms, suspended ceilings. Someone needs to get rid of that comma there. And exhaust ducts. So both agencies, they looked at it and they go, okay, this is kind of the where these are going to be used. Now, UL adds a constraint. These products are for use in 1313R and 13D occupancies. We had a call come into Reliable Technical Services last week. Dear Mr. Reliable Technical Service Manager, may I use flexible drops on an AFFF or fluorine-free, if that's the version, foam system? And from a standing back, without getting into the details, you look at this and you go, wow, there's no reason it shouldn't work, right? There's nothing that says you can't, unless you're in the UL world and you look at this and go, okay, wait a minute. Yeah, I see now that 13R and 13D, I don't think there's too many foam systems referenced in those documents. So the answer to that question, at least in the UL world, had to be no. They're for use in these particular occupancies. So keep that in mind. That being said, however, NFPA in most of their installation documents. In 13, they would call it new technology. I glanced at 15, for instance. There's a section, and this may be a little bit older language, but they had what they called equivalency, which essentially says the same thing, right? If you have new technology that you can present to an AHJ on a performance basis, based design and get it approved, then yeah, you could do this. So I wouldn't necessarily rule out using the flex drops on a foam system, but you're going to have to go through a little bit extra legwork to get that done. Now, what FM adds is simply other applications shall be looked at on a case-by-case basis. So again, with FM, they provided the AHJ is on board with it. They have a little more latitude, so to speak, with their particular projects that they oversee. So here's a couple more basics where UL and FM maybe not see eye to eye. I hate to use the punching bag, the gloves there, because it seemed like they're fighting, but they're really not. It's just that they essentially don't agree here. So where UL allows braided or unbraided hose, FM requires braiding. You won't find an FM unbraided hose to my knowledge. UL will tell you that the product shall be constructed of metallic pressure retaining components. In other words, the bellows on the inside, it's going to be metal. It's going to be rated to a minimum pressure of 175. FM, on the other hand, again, 175 PSI, but they would allow for a PTFE convoluted hose on the inside of the braid. I don't know if there are any out there. Most of the time it's stainless steel, but in any case, FM would allow that. UL maximum length 6 feet, FM maximum length 8.5 feet. So a little bit of difference there, not really too much to worry about. I do know in sitting on the committee meetings that one of the manufacturers is proposing a 12-foot length of flex head. So that may be coming. I don't recall exactly where it got to in the approval process, but there's talk about longer versions already of the flex drops. So let's take a look at the test requirements, and this isn't everything, but these are the performance test requirements for flex drops, and we're going to look at Underwriters Laboratory, and we're going to do a kind of a side-by-side comparison with FM. You'll see, again, some similarities, some differences. In this case, I'm going to take these 15 tests, and I'm going to scratch 3 of them. The equivalent length determination is really just a kind of a listing deal. The elastomerics parts test for UL is more of a specification, as is the metallic coating thickness test. So those remaining 12 tests there are functional tests that the flex drops need to pass. If we look at factory mutual, we're going to see a list of 10 tests here. And we're going to essentially throw out, again, 2 of these, the equivalent length test. We're going to throw out their kind of bucket item of additional tests. And then bear in mind that the seal integrity test, and we'll talk about that, is essentially the same as the high temperature and low temperature tests for UL. So you really end up with 9 performance tests for UL or for FM, and you end up with 12 for UL. And let's take a look at those, and I'm going to kind of go through them in the UL since they have more, and we'll look at each one of these. So a pressure-related test for UL. You're going to stretch the hose out flat. You're going to measure it end to end. Pressurize it to 20 PSI, measure it from end to end, and then pressurize it to 1.5 times the rated working pressure, and the drop cannot extend by more than 1/8 of an inch. So that's just to make sure that the products, everybody knows you put a lot of pressure on something that energy is trying to go somewhere. It's going to try and distort from end to end. Once that's done and we've passed the distance test, we're going to pressurize it at 2 times the rated working pressure, and we're going for leakage, and then we're going to pressurize it 4 times the rated working pressure to make sure it simply doesn't rupture. I presume it could leak at the 4 times test, but it simply can't obviously rupture. Factory mutual, a little simpler. No rupture, cracking, permanent distortion, or deterioration at 4 times the rated working pressure. So not necessarily concerned about how it extends unless it had some effect on any of those issues, the performance and so forth. So the next test, a mechanical strength test. And quite simply, all this one is for UL is to anchor the flex drop in the ceiling tile using the approved fasteners and put in a fire sprinkler to a 60 pound-foot torque and see if things hold up. Right, so on day to day, we've got to be able to make these fire sprinklers in out there if they're not made in on the ground. But 60 pound-foot of torque is quite a bit. A normal half-inch fire sprinkler could be somewhere in the range of 13 to 18 foot-pounds, and 11.2 may go up into the low 20s. So it's a pretty good safety factor in terms of twisting the assembly once it's anchored to the ceiling. FM, not really a test for that, unless they said, we're suspicious of your brackets and we're going to require that additional test. The high temperature exposure test, right? So in these parts, somewhere a seal is being made or more than one seal. And those are typically being done with an elastomeric or rubber part. So UL is going to take a look and they're going to have distinguish between a high temperature test and a low temperature test. FM is going to simply call this the seal verification, and they're gonna put it kind of into one. So again, the high temperature test for UL, you tell them, or we would tell them what temperature we anticipate this to be at. They're going to tell us at what temperature to expose this to for 90 days. We're going to put it in the oven and let it cook. And then at the end of that, we're going to have no leakage or rupture at 2 times the rated working pressure. FM will just simply again say no cracking, leaking, permanent deformation, or deterioration after 45-day exposure to a set temperature of 275 degrees. So take it out, test it, make sure it holds. Additionally, FM will pull the rubber parts out. So imagine something like a hose washer. You're going to reach in there and remove it and essentially pinch it from side to side and make sure it holds itself together. And that's their seal verification test. The vibration test. So imagine that you take the fitting end of the flex drop and anchor it to the wall. You then take that flex drop and you bend it 90 degrees downward and you attach the sprinkler end to the vibration table. At UL, they're going to vibrate it left and right. They're going to vibrate it from you and away from you, and they are going to vibrate it up and down. And they're going to do this at a number of different frequencies. These are all spelled out in the test standard. And afterward, they're going to hydrostatically test it at 2 times the maximum rated pressure. Now, they go a little bit further. If anybody's, and I'm sure most people have, right? You have that one bass note in your car where that speaker just seems to want it to sound like it's going to fall apart, right? Everything kind of vibrates and you're like, wow, I got a crappy car. Well, it's actually a natural phenomena. It's called resonance. And resonance is when the test frequency gets very near to the natural frequency of the assembly, be it your car speaker in your door or the flex head. And you've probably all seen this. There's one spot where everything kind of just goes wonky, and that's resonance. And what happens at resonance is that the vibration amplitude is magnified more than what's being put into it by the vibration table. So if you hit resonance at any one of these frequencies at UL, instead of 5 hours at each frequency, let's say you hit resonance at vibration frequency number 2, the remaining 25 hours are held at resonance. You don't get to just bypass it and go, wow, I'm glad we made that 5-hour period. No, you got to hold it there, because that's when the assembly is trying to destroy itself the most. So they would throw that in there. Again, FM a little less on the vibration. Similar setup, again, down to the vibration table. They don't go into a lot of detail about side to side, up and down, and all that. But they do require a 4 times rated pressure hydrostatic test rather than the 2-time vibration test. Salt spray corrosion. This is kind of an interesting one, right? Think about where you're using these. It's above a ceiling. Now, granted, it could be in a little bit more harsh environment. But again, UL is going to look at an actual test and it's going to be similar to a sprinkler test, right? A 10-day exposure to a 20% salt spray. And what they're looking for is what they call incipient corrosion. And we'll talk about that in just a second. FM does not test for this, but in their materials section, they simply say that hose parts exposed to water. Now, that could be taken a couple ways, like the inside of the bellows, but I think their intent here is that, yeah, we don't want to just put, black steel out there, and have it sitting in an environment where it's going to rust up, right? We want to do some sort of a plating or coating on it. Could be galvanized or zinc plated or whatever it is. But they just simply address it in the materials section rather than an actual test. So let's jump back to this incipient corrosion real quick again, because I do want to make a point here. So they actually define it in the test standard, and it's not, wow, that looks bad, right? It is the first evidence that the material is being destroyed, which will affect the product. So I bring this point up because I'd like to relate it to a fire sprinkler corrosion test, right? We've done webinars on this. All fire sprinklers are exposed to 10-day, all of them, not just corrosion resistance, all sprinklers, 10-day exposure to salt spray, and a couple other chemicals. So they're being tested as well. We make the point when we talk about this that the pass-fail of the sprinkler test is not how it looks. It's how it functions compared to its out-of-the-box state after it's been exposed to these tests. So what we're looking for with regard to sprinklers is incipient corrosion as well. We're not talking about the aesthetics. So kind of keep that in mind. There's a little bit of a correlation between that salt spray test here and the salt spray test and other tests of the fire sprinklers themselves. So this is an interesting one here. I think it exists, but I'm not sure how widely it's used. Not knowing a lot of the details of all the flexible products out there, I don't know how many of them actually use brass parts. But if they meet this requirement at UL, you will do a moist ammonia air stress cracking test. Basically, it's tested under stress in its bent state, assembled and pressurized. And we're going to expose it to aqueous ammonia, 93 degrees. And you'll see one of the other tests coming up. You go, wow, why at these high temperatures? I mean, what's that all about? We're never going to have these things sitting there at these high temperatures. Remember in chemistry that chemical reactions speed up at higher temperatures. And so in order to mimic a long-term test, you either can set it in there for a long term, or you can attempt to correlate the chemical reaction by raising the temperature. So in this case, they're going to take it up to 93 degrees, 10-day exposure, following which you cannot have any evidence of cracks under 25 times magnification. Now, that picture on the right that looks like either a blood vessel or maybe a river system or something like that is actually a metal stress crack that is starting to form. So, and another example of that, by the way, think about when you take that rock pebble into your windshield. And right, you look at it and you go, well, there's a little spot there. Well, I'm glad it didn't crack the glass. And then what happens? You come out the next morning and all of a sudden it's an inch off of each side of that chip. And over the course of the day, it starts working its way out. It spiders out from that. That's another example of a stress crack, because that windshield is being flexed and expanded and contracted. And at some point, if it's got a breach in it, it's going to fail. So similar situation here. FM simply looks at it and says, we're not gonna deal with it every day, but we may require an additional test. So again, from a manufacturer's standpoint, you kind of got to take it in there and go, are we going to have any additional tests that aren't listed here? And they would probably tell you yes or no. So another type of cracking, not necessarily stress cracking, go back one, the air stress cracking. This is going to be for stainless steel parts. And this is going to exclude the exterior braiding and the fasteners if you're using, stainless steel screws and things like that. Really what we're talking about here again is the pressure holding parts, the ends of the flex and the internal bellows. And this is set up, the sample is bent to a 90 degrees at its minimum radius. It's put over 150 hours exposure to magnesium chloride solution, what we call boiling magnesium chloride at that very high temperature of 302 again. That's to get the salt chlorides up into the air. It also speeds up that chemical reaction. Following that, we're going to look at it again, 25 times magnification, and make sure that stainless steel is holding itself together. And then for factory mutual, they don't concern themselves again with the stress cracking, or it's an additional test. Now, boiling magnesium chloride sounds really ominous, but in reality, magnesium chloride is simply a type of salt. It's very, very prominent, fourth most common element on the earth. It's the 11th most abundant element in your body. And it's responsible for about 300 enzyme reactions in your body. So if you're on the health circuit, or you hear people talking about, well, I need to maybe take some magnesium, that is why. I would suggest you don't drink it at 302 degrees, however. So the low temperature test for dry pipe systems, again, what are we looking at here? Well, we're looking at things contract when they get cold. The metal parts are probably going to be okay, but what's going to happen with these elastomeric seals and things like that? So we're going to take a sample of our flex drop. We're going to put an 1/8 inch deep depth of water in the bottom, probably to mimic some condensation that was not able to get out of the flex drop. We're going to pump it up to 40 PSI. We're going to put it at minus 40 degrees or minus 40 degrees centigrade. Keep in mind, those are the same. If you look on the airplane when you're flying and you go, wow, we're at 33,000 feet and it's minus 40 Fahrenheit and minus 40 Celsius. So that's where those two kind of cross over there. We're going to expose it to that temperature for 24 hours. We're going to let it return to room temperature for 24 hours, and we're going to see if it's still at 40 pounds. FM looks at it just a little bit differently. Again, they're still at the minus 40. They're going to put it in there for 4 days, after which time we are going to pull it out. We're going to immediately submerge it in antifreeze. We're going to pressurize it with air to 50 PSI and make sure it doesn't leak. And again, that's to make sure that the seals at the end of the rubber seals are doing their job. And once again, FM is going to pull out one of those seals. They're going to pinch it side to side and make sure that it doesn't break in half, or some other fail in some other fashion. Pressure cycling. So this is kind of the water hammer, right? We're going to pound this thing with water hammer over and over and over to make sure that those minor shocks that happen over and over and over don't damage the product. So at UL, we're going to test it in its straight condition and with its maximum number of minimum bends. We're going to pressurize these things. We're going to cycle 3,000 cycles. between 0 and 350 psi. If it's a 175, we're going to do that at 10 cycles per minute. And we're going to make sure that afterward we do not have any leaks. FM is going to bend the hose 90 degrees, 20,000 cycles, not 3,000, 20,000 cycles. Again, although not at 2 times the pressure, working pressure, 20,000 cycles. And again, we're going to hydro it at FM 4 times the rated pressure, not 2 times the rated pressure. So you kind of see some give and take in terms of how much more are we going to hydro it versus how much less are we going to hammer it, things like that. I guess at the end of the day, one thing to keep in mind is that when you get a UL/FM product, it has undergone some very, very rigorous testing, and there should be absolutely no reason to think that there's going to be a problem with these products. And so again, all manufacturers that want to be in that UL/FM market going through these tests. A vacuum test. The vacuum test is primarily to make sure that when you pull a vacuum on the flex drop that you don't collapse the inner bellows. So in the case of, again, maybe that PTFE bellow, if someone were trying to get one of those approved, you would want to make sure that it's got strength. In the FM world, the outer strength is going to come from the braiding, but the inner strength needs to be maintained by the bellows. So at UL, we're going to pull a 1-minute vacuum at minus 8.84 psi. No leakage, followed with a pressure test, again at 2 times the rated pressure. FM is simply going to pull 1 minute at minus 12.8, and we're going to have no leakage. Again, they like the 4 times maximum rated pressure rather than the 2. So, and again, on the right there, nature's most powerful vacuum, right? The black hole, so strong that even photons of light cannot escape. High pressure flow test. We want to make sure that we don't turn our flex drop into a water rocket. So we're going to anchor this down. UL is going to be looking for no more than 1/8 upward movement at 90 degrees hydro pressure, followed by 30-minute flow at 90% of the rated pressure using the largest proposed K factor. So again, we're just going to let the water blast out of the sprinkler and make sure it stays where it needs to stay. FM is going to do a similar test. It's going to be done with a commercial suspended ceiling assembly, not just a bench or a board. And what they're after is, again, no deterioration of the components. They're going to do 7 pressure tests in 30 psi increments from 10 to 175, to make sure that the components hold together and don't lift up off of the test board. So finally, the fatigue test, what's called a fatigue test. So imagine you've got the flex drop in your hands, one end in each hand. You bend each end upward into a U shape. You anchor the left side to a wall or a hard surface. The right side you attach to a piston that is going in a vertical position. That piston is going to go up and down. Up and down, 4 times the diameter, the distance it's going to travel, 4 times the diameter of the flex drop that you're testing, up and down, over and over and over again. UL looks at what they call a high flexibility hose. In that case, we're going to be looking at 50,000 cycles up and down. So attempting to fatigue those internal bellows, be it whether they're a spiral or a concentric version of that internal hose, and we're going to be trying to break that material apart, typically at that lower U bend areas where this would happen. If you're doing a limited flexibility hose, or what they call limited flexibility, it's only 100 cycles. I believe that most of these are going to be in that high flexibility 50,000 cycle. And then what they're also going to do at UL, they're going to imagine you, again, let's say you've got your flex drop in your hands, one end in each hand. You take the minimum bend radius, let's say it's a piece of pipe, for instance, and you essentially bend it 90 degrees over that pipe. So that's the test, back and forth, bending it over the pipe, that minimum bend radius, not just a U shape, the minimum bend radius. And after that, which time we're going to have no leakage at 5 times the maximum rated pressure for UL, 4 times maximum rated pressure for the factory mutual. So the fatigue testing, where do we normally hear that, right? You normally hear about fatigue failures in aircraft. It seems like a lot of turbine fan blades and things like that, they'll chalk it up to fatigue failure. And one of the most famous, fatigue failures, infamous, maybe a better term, the very first jetliner in the late 1950s, the British de Havilland, renowned to be the first jetliner, was only on the market for about three maybe years. Because of what you see on the picture there. And that's actually a picture of a stress fatigue crack in the fuselage that sent a couple of those planes down with some substantial loss of life. So that's what we're after there, to make sure that during regular use, we don't have a problem with components in there. So again, 50,000 cycles at 5 to 30 per minute for factory mutual. So those are the tests. So hopefully, again, you've got a good picture that this thing has gone through a lot of testing. The next part of this is going to be pretty quick. The NFPA 13 requirements, as I mentioned, essentially 4 statements. This is where it's at in the 2019. Number 1 is kind of the Homer Simpson duh, right? Got to be in accordance with the manufacturer's instructions. This is kind of an interesting one, because this tells you, the sprinkler contractor or the engineer, that whatever sealing going in there for this product to comply, that sealing has to comply with those ASTM standards as well. So make sure your sealings are complying. The unsupported length cannot exceed 6 feet. So when the 12-foot drops come out, you'll be looking at 2 hangers on each of those as a minimum. And then finally, NFPA, not the agencies, but NFPA requires the sprinkler relocation warning label, and you can see an example of that on the right. So one of the early promises made with this was, wow, when you go do TI work, you can simply hop these over to the next tile and move these around. Well, primarily the AHJ world got a little bit concerned that Mr. Owner might be out there doing that himself. And so this is the attempt to essentially thwart that and say this must be done by a sprinkler contractor. So what about those seismic considerations? Well, really the only mention made is where sprinklers pass through the ceiling primarily. Now, 18.4 is kind of interesting, because it actually talks about pipe which passes through material. And so you go, well, how can sprinklers comply? It's talking about pipe. And this is just one of those interesting things that you see in the standards writing. It doesn't say you have to worry about sprinklers, but it kind of does, because right here it tells you where they're installed. Using the flexible drops you don't need to provide the clearance. So the other part of that is, if you're not using flexible drops, you need to provide some type of a clearance. So again, what are those alternate methods if you're not using a flexible drop? Well, one of them is the suspended ceiling can be seismically designed with the cables that go up on different angles, and that ceiling now by design is intended to move with the rest of the building. That's one way of getting around the flex drops. I don't know again how often that's used. And then the second way through the ceiling tile itself is to oversize that hole and provide some clearance like we would for pipe, so that sprinkler drop can move around in there. And the issue there, of course, is now I've got a hole that's too big for my standard 2-piece or my cover plate of my conceal sprinkler. So what do I got to do? I got to come back in with either some seismic excussions, the large oversized one, which Reliable also offers, or the OOPS plates that go on kind of underneath those underneath the trim rings. So what are some design considerations? So number of bends, right? Think about why we coil things, right? We coil things to save space. And so if you're simply buying a flex drop to put into a space and coil it up because there's too much of it, you're kind of wasting money. So again, think about what you need. We use these again in lieu of hard offsets. So you don't randomly go in and throw in hard fitting offsets. So why would you necessarily need a drop with a huge number of bends? Unless, and please don't misunderstand, unless you want to be a little bit lazy about your design. Maybe time-wise, you just say, look, I don't have time to figure it out. Give them everything they need. That way I can get on to my next job that needs design. So that's one way of thinking about it, I guess. So how about the radius of the bends? So shorter is going to be better, right? It seems like shorter should always be better, but at some point you're going to start impacting your friction loss. And at some point, you're also going to reach the physical limits of that drop being able to bend sideways, at which point you're going to be probably looking at some sort of a hard fitting elbow to make that difference up. The equivalent length. This is always better, right? It's going to, at some point, if I can save friction here, I can use it in other places. Just remember that bend radius, number of bends, those all affect the friction loss. I can offset it, or we can offset it with larger diameter, but there's going to be a cost impact there at some point. So find that balance. The sprinkler fitting, a straight one or an elbow, again, maybe the need to get tight over a ceiling and drop down under a duct or whatever that is, that's nice to have. One of the things I would throw out in there is, think about alternate ways that this could maybe be used. Maybe you've got a situation where you need a horizontal sidewall and you want to drop down in a wall space. So think about other ways that these can be used, right? There's nothing, at least that I know of, that says you couldn't do that. You may have to convince an AHJ, but again, no reason to say that we couldn't do something like that. Working pressure is an issue, right? We see a lot of places where we need maybe the 250 or 300 PSI, so we'll be looking at that. So best practices. Scarecrow had a brain, right? He always had the brain. He just needed to be told he had the brain. You've got a brain, so let's use it. Again, please don't take offense to any of this. But first thing I would say is, right, obviously follow the manufacturer's instructions. Don't guess or take chances. It's much better, obviously, to call us or the other manufacturers and say, I'm thinking of doing this. Is it possible? Let us work for you and help you on the front side, because it's much easier to do it then than it is on the back side. Again, think outside the box. Use these as a tool to solve a problem, but make sure again that the manufacturers are on board with it before it gets installed, or you'll be potentially looking at trouble down the road. Cutout waste. So again, I said there might be some things in here that necessarily aren't flex drop directly related. So here's just kind of some key things that I always tried to keep in mind as a designer. Cut out your waste, but don't cut yourself short. If you put in a flex drop that's too short, you've wasted your time. So your fitter's going to have to be back out there extending it. If you put in a 6-footer when you need a 2-footer, you're wasting stuff. So think about things like that again, depending on the policies of your design department. And then finally, just a couple things here that I always like to keep in mind. Draw smart, not hard. Keep the fitter working in a straight line. This is kind of maybe for some excuse me, for some younger designers, right? Things to keep in mind. Keep your fitter moving in a straight line. He's going to be much more efficient that way. Don't have him go side to side. Think about which offset makes more sense from a cost standpoint. And this is where I'll probably offend a lot of fitters, but I've said it to them before, and a lot of guys will shake their head yes. Avoid the fitter having to think, right? And I don't mean that they're not capable of doing it, because they are capable of doing it. It slows them down. Your boss would much rather that they are simply on autopilot out there. They're going to have a much better day, and they're going to like you much more if their day goes better. So those are kind of just some best practices from a flex drop standpoint. And then finally here, we are about done. Future enhancements. What do you guys need? Part of our job is to play, to play the great Karnak here, but we are not as good as he is. So let us know what you need. So what are some of those things? Do we need more bends? If so, we can look into that. Do we need tighter bends? Remember the limit, however. We're not going to be able to make this thing turn on a dime, literally. Do we need the longer ones, right? What is the market for a 12-footer out there? Is that something that is going to be used? If you think it is, get in touch with us. Let us know. Reduced friction loss, always a good thing. Again, got to be balanced against the additional cost of going to that larger diameter. So we would be maybe willing to look at that. Accessories, if we don't have something, and Reliable's got a great range of accessories with the Rasco Flex. But if there's something there that you look at and you go, man, we need these, let us know. Those are fairly easy to accommodate. And then finally, what else you guys need? Again, going back to number one, just let us know, communicate with us. We'll work with you and we'll help you solve your problems. So with all that, again, I'd like to thank everybody for attending. We're about 1 hour right now, given our few-minute late start. And at this point, would be happy to take any questions that are out there.
We have no questions in the chat. Excellent job.
No questions in the chat. Okay, we put everybody to sleep again. All right, well, I appreciate that. Thanks again, everybody.